Yeah. Next one is Mr. Jaanus Padrik from company Hendrikson and Co. The title of his presentation is Use of Custom JavaScript Web Apps in Spatial Planning. Hendrikson and Co. is a leading company in city planning. So please.
So, hello. My name is Jaanus, and as said, I'm representing the company Hendrikson DGE. We are the Estonian office of a larger Scandinavian group called DGE. We have also offices all over Scandinavia, and we have 20 plus years of experience in the field of spatial planning and environmental consultancy. Our company comprises of 7 different teams. We have about 40 experts in varying fields of expertise, and the team I'm representing today is the team of spatial planning. So what have we been doing in our team and department? There has been a wave of comprehensive plans in Estonia in recent years. So we have been compiling over 10 comprehensive plans for Estonian municipalities, and also some larger nationwide plans like Estonian Maritime Spatial Plan, the Estonian National Spatial Plan for year 2050, and also lots of site selections for major infrastructure objects like the Baltic railway part in Estonia, and also different large-scale factories and highways and so on. And another aspect in our work has been the boom in renewable energy in recent years, because there has been a huge growing interest in wind and solar parks by different developers. And for us, it has been a great opportunity to combine our expertise of spatial planning with our wildlife and nature experts. And what we have been trying to aim for is to develop a complete package of services for the developers, starting from initial countrywide site selections for the parks and going all the way to detailed plans for when the specific locations for the wind parks have been selected, and that includes helping with all the common planning bureaucracy also. And these are some of our clients that we have been working with. To go on to the part of our web apps, so this is the technology that we have been using. First of all, ArcGIS Pro for all the data management, analysis, and also the different extensions the software offers. Then we're storing all our data in ArcGIS server. And we also are using the ArcGIS Enterprise for managing users for access for our web apps. Then on top of that, we're using the ArcGIS Maps SDK for the base functionality of our apps, and we are trying to combine that with our own custom HTML and JavaScript codes for furthering the functionality, and also making custom designs with CSS. So I'll try to show some few live examples. Hopefully everything works well. This first example is a comprehensive plan for the city of Narva in Estonia. Narva is a border town with a shrinking population, and the plan that we are compiling is trying to manage all the challenges that it proposes. And this is a 3D view of the plan. We are using all the existing buildings from our Estonian land board, as you can see, and these yellow areas are the small residential areas that we are proposing with the plan. And the purple line here is a line that represents from where we want to make the city more compact, so that the shrinking of the population will be more manageable. And as you can see, we have a lot of large residential buildings on top of the small residential building land use, and this is where the 3D applications really help to make the plan more understandable, because in the future we see that a lot of these large residential buildings may be left empty, and we want to rather make changes in the land use in these areas. And now, on top of these data layers here, we have added some functionality for planners and also for decision makers in the city. For example, when we want to experiment what happens when we plan some new buildings, or want to demolish some existing buildings, we can use some tools that we have created. For example, let's draw a spatial filter around this building that erases it from here. And now we have option to sketch some new construction here. So this slider here gives the height to the new building. Let's make it 50 meters, for example. And now I can start drawing the shape. So now when the building is done, I can also play with shadows, lighting environment, and when I click on the building again, I can adjust the height to test out some other options. And now another cool function that we have made here is when I set the viewpoint to center around the building or some other place, I can just click a specific key on the keyboard, and the view automatically starts to rotate around the set center point. And I can also set it to full screen to give a better perspective of what can be planned. And as you can see, there are some other additions to the existing buildings. For example, these purple and red boxes here. These are we have gathered all the existing detailed plans and tried to visualize what it would look like if all the plans were actually to be carried out. And the purple boxes here represent the historical building sizes that were destroyed in the bombings of World War II. So the city used to be a lot more denser, as you can see. So the next example, just make a quick refresh here, is kind of a specific product that we have developed for wind and solar park developers. that they can access with their own user and password. And the purpose of it is that they could manage their own wind park projects. Here on the side, you can see these panels for all the wind parks that may be proposed, and we have an editor widget we can use to place new windmills. For example, let's put one here. We can give the park some name. Let's name it just tests. We can set the power of the windmill and the extent of the blades. Let's put like 60 meters. And automatically in the background, when the windmill is placed, it queries the cadastre unit that it was placed on, and it also stores the data in the attribute table. And so when the windmill is created, as you can see, there's a new panel in the park section. It shows that at the moment this park contains one windmill with a total power of 7. Now, if I add some windmills with the same name, it summarizes these numbers. And as you can see, when the windmill was placed, it automatically made the buffers. The smallest buffer is the extent of the blades that I just inserted, and there's also 3 more buffers, 1, 2, and 3 kilometers from the windmill, and also an automatic query to get all the residential buildings inside these buffers that are represented by these gray dots here. And now when I click on the buffer, it should calculate the number of the buildings also that are inside the buffer, which is in this case 40. In addition to this, it's also possible to insert data for all the cadastre units. First of all, we have a filter here that allows the filtering by land ownership. For example, private property, state-owned lands, and municipality lands. And when a specific land unit that is of interest to the developer, then it's possible to insert also data for the land unit. For example, the name of the owner. Add some status. Is the contract in negotiation, or is it a land unit of a competitor? Leave some comments here. And when I add the data, it automatically shows the color of the category I just gave it, and also the name of the owner and other data in the pop-up window. Yeah. And I'll show you quickly also the drawing of the solar parks. I can insert them as I did with the windmills. I just start drawing some shape here. Let's make it an more interesting shape. And similarly, also all the cadastre units are queried here that are intersecting with the shape. I can also give it a name, status, like before. And as I create the park, it now automatically draws the possible solar panels on here. As you can see, it closely follows the shape I drew. And when I click on the solar park, it also calculates the summarized area of all these potential solar panels in this last line here. So let's move on. Another example involving wind parks is a wind park plan for the Haljala municipality in Estonia. These green areas are the possible suitable areas for wind parks. And now thinking about the local residents and the general public, we made a custom search tool here that allows people to search for their own the address of their own homes. In the background, there's a request to the land board address API, and I'll just insert some address here. It gives a suggestions which one I want to use. Take this one, and now it returns the coordinates of the found address, and it finds the closest geometry from the suitable areas layer. That are the closest to the coordinates, and then also the closest coordinates of this area to the found point, and it takes the two points and creates a line between them, and also shows here in the pop-up the length of the line. So it is a convenient way to find quickly how far the wind parks may be planned from your own home. So, and the last example here is also involving wind parks. These are similar suitable areas as seen before, but in another municipality where the planning is in a state that also the positions of the windmills are in place, and we've tried to show these locations in 3D. These models have a correct height of the real models that are planned there. And also we are using the same existing buildings from the Estonian land board. And here is another actually similar search widget as before that allows to search for the address. And now when the address is found, the camera automatically zooms into the location of the house. It also gives the distance to the nearest windmill, and the pop-up window also has a small button here that allows to turn on the vegetation layer. So you can get a good idea how the potential wind park may look from your own house. And also you can set the lighting conditions, see the shadows that the wind park may or may not cast over the houses. So, but I think this is it from me. Thank you.
Thank you, Jaanus. This is really a comprehensive application you've created there. Questions? Slido questions, maybe?
Yes, from Slido we have 2 questions. Are those web apps are developed in your house, or you need some external help?
No, this is fully our in-house development. we're just using as I said, some parts of Esri technology, and we are building our own functionality on top of that.
Okay, and then the second, this is also a little bit technical, but how are you taking into account limitations in power grids, for example, when performing calculations? So the existing infrastructure, did you somehow take it into account?
I think it's an aspect that the developers themselves are handling themselves. I think because we are as I showed the app for the wind park planning. We're giving it to them as a tool, so there's also like reference data for all the substations and power lines, and they are making those sort of analysis by themselves. And
Okay, and one question for me. As GIS data are tightly connected with all kind of data, and such nice and advanced planning companies like Hendrikson you are becoming a source of the new data, GIS data, building houses, planning new areas, so on. Do you have any mandatory activities with local land boards or some municipalities to share the data immediately with public or with public services?
In Estonia, we have this quite new system called Blank, that is the nationwide database that should compile all the plans that are being finished. So we're sending all our plans and spatial data of the plans to the Blank system, and then that's kind of the portal to put it all together and share with people.
And the Blank is managed by land board, or?
I actually don't remember
Okay,
who it
no
is
problem.
specifically.
Thank you. Any more questions from audience? If no, thank you very much.
Thank you very much.